In today's video, we'll take a look at enumerations in C. They are very similar to structs, since you may remember that structs are basically user-defined types that encompass many variables. Now, in our case, an enum is really a user-defined type that can only have certain values, right? So to start off, to define an enum, just say the enum keyword here, then a name for an enum, let's say color in our example, and then as with any struct, you would just have a body of the struct here, and what we enumerate inside these brackets are the possible values of this enum. So here I can say, for example, red and blue, right? The words red and blue specifically. And now I basically have defined an enum, a user-defined type that is called color, and it can only have two values, red and blue. Simple enough. So now we can use this enumeration like any other type inside the system. So we can say here color, let's say C equals red, right? And now I'm gonna get some errors because it says that identifier color is undefined. Well, why is that? Because we already have defined it here. That's because enums, similarly to structs and unions, work the same way, where they don't actually have, you don't actually have the name, the identifier color inside your type namespace. Instead, you actually have to prefix this with an enum keyword. And then it's going to know that, okay, so you're defining here a variable called C of type color, which is an user-defined enum. All right, that's fine. So here I'm going to just print F. I'm going to use %d because we're going to see in just a bit why. And I'm going to actually just type in the C variable where we have the value red. So if I try to run this, I'm going to get, well, the value 0, which is to be expected because every single name here, every single value, so to speak, inside this enumeration is associated an integer value. And as you can see, the actual the editor in this case is automatically detecting that red is the value 0, which is what we saw here. And if I mouse over blue, you're going to see that blue is equal to 1. So if I change this to blue, I'm going to get 1, right? But you can actually change these values if you really want to. You can say, for example, red equals 7 and blue equals 8, right? And if I try to run this, I'm going to get 8 for the fact that C is actually blue. And if I change this to red, I'm going to get 7. Now, if I try, for example, to say here yellow, well, yellow is not something that exists, so it's not going to be identified as a valid value, right? Doesn't exist. I have to really just say here, to type in here yellow, and then it's going to see that, oh, okay, so this is the identifier, so I can actually just equal it. And then when I try to run this, let's give it the value 9. I'm going to get the number 9 on here. So now that we have 7, 8, 9 here, we can actually, instead of having all these numbers here, we can simply remove the last two and just leave red equals 7, because if I run this again, you'll notice that I get 9 on the screen as before. And that's due to the fact that if you don't specify any number, any constant expression as it said in the specification, after the identifier here, it's going to just add 1 to the previous value. And that means that blue is going to be 7 plus 1, which is 8. And then yellow is going to be blue plus 1, which is 8 plus 1, which is 9. And that's why I'm getting 9 here, right? So if I were to change this to, for example, a 4, you'll notice that yellow is now 6, right? So we're printing here yellow and it's 6. Now, to get rid of this enum prefix, like any other struct or union, all you have to do is prefix this with a type def. Just say type def here, and then type in the name of the enum again over here. Or you can or you can do that afterwards. It's really the same thing. You can say type def enum color to color. Right, so I'm just type defing this guy to be this guy, so we don't have to prefix it with an enum. Right, so I can do this now. So if I try to run this, it's going to work as intended. Now, as you can see, enumerations inside C are that simple, right? You just define the type and then its values, and then optionally, if you want, a different numbering system for them, and that's about it. But I'm covering them due to the fact that many people, myself included, have used macros instead of enumerations when they should have used just enumerations, right? So in our case, if I try to debug this application, you'll notice if I just put a breakpoint here and try to run this, you'll notice that C here is detected automatically as being yellow, like the word yellow is inside here, not just 6. So it's very compatible with the debugger itself, and you can actually see the value inside here. If I were to, for example, have used a set of macros, just like so, you'll notice that if I try to debug this, well, C is just the value 6. It has no sort of, you have no type for it. It's just int here, or maybe just unsigned int or whatever. There's no type for it, and it doesn't say the significance of that 6. So you kind of have to go, oh wait, this 6 is actually coming from here because I have defined here a macro that's yellow. So that's why enums are much better to use, because it's easier to debug and work with them. Now, there are some limitations with enumerations in C, and that is here you can only have integers. In fact, all the values inside an enumerations are going to be converted to integers. Whatever else you might want to actually store in them doesn't matter. So if you have a, let's say, a flag system, you're only going to have 32 bits to work with. You're not going to have any more than that. So if you have a flag system, you might want to look into using macros or other things like. And that's about it. Thank you guys so much for watching. If you do have any questions, do leave them down in the comments below or on our Discord server. Take care. Bye.